Hi hello everyone, welcome back to my channel. So in last class we are studied some derivation path, how to draw the shear force and bending moment diagrams for cantilever, simply supported like that for different types of loads. So all the basic concept of that we want to put here now here. Why? Because this is a problematic manner. So in this, at what load, at what distance, how it will be acting, all will be shown here. So in question, draw the shear force diagram and bending moment diagram of for the cantilever beam as shown in figure below. So they will give like this question, or else they will give some information regarding the how the load, where the load, at what distance load is acting. So all give information. According to that, we want to draw this diagram. So in some case they will give this one, in some case they will not give. They will not give. So for that we want to write this like this. And after giving this question, first of all we want to draw the shear force and minimum diagram in one side, and another side is calculation. Wait. So like this you have to maintain. So one side is for diagram and another side is meant for calculation part only. Or else divide the paper into half. One half is you can write calculation part and another half is you can write the diagrams. So first of all we want to consider the portion BD. So after considering portion BD, you want to divide a section between XX here at a distance of X meter from the free end. See, like this. So now we are only considering portion BD. So this is very simple calculation. So simple to understand. Everybody can understand by this kind of procedure. So first of all we want to consider the portion BD. No, for that purpose I am taking only BD. So here we want to divide this section XX in between BD at a distance of X meter from the free end, because it is a cantilever beam. Further, it is a distance from section XX to the free end is X meter. Total is 2 meter length. BD length is 2 meter. So we are dividing section X meter from free end. So now we divided the section. So after dividing the section XX, what is the right hand side present? So what is the load acting in right hand side? So that is we want to consider only shear force. So in shear force we will consider only shear load only. That means in right hand side what is load, how it is acting, and upward to downward it is acting. That means it is a positive, that means plus 10 kilonewtons acting shear force. Shear force is plus 10 kilonewtons. And after that it is, now we want to draw the bending moment. No, for that we completed the shear force, and bending moment is what, at a section XX in between. So force into distance is the, or force into perpendicular distance is the bending moment. That means minus 10 into x, 10 into x. So this is a bending moment. So now we completed the portion BD. So shear force is plus 10 kilonewtons and bending moment is minus 10 into x, because it is moving in clockwise direction. No, for that notation. So for shear force one side and bending moment is one side. So now likewise, now divide this consider the section CD. Now you divide the section XX in between like this. We will consider now CD portion and BD portion. Why? Because we are coming from the side at one end to another end. No, so we are coming from end to this. No, for that we want to section consider this one as well as plus CD. So now we want to divide a section XX at a distance of X distance from the free end. So now divide the sections. After in right hand side what are the loads acting? So here we are acting two kinds of loads, that is all point loads. For that shear force is what, plus 10 plus 20. So that is equals to plus 30 is the plus 30 kilonewtons is the shear force of portion CD. So now likewise bending moment. Bending moment is what, force into distance. No, force is 10 kilonewtons at a distance what, x. 10 in minus 10 into x minus 20 into x minus 2. Why? Because it is load is acting towards the central xx. So x, no, and next is this 20. So 20 into x minus 2. Then because central, that means section xx to the free end is x. So this BD length we know 2 meters, because x minus 2 we get means then we get this value. Section xx to the point to d value we get x minus 2 means we get like this. So this is the bending moment diagram. Next, likewise, consider the section AC. In between again we want to divide the section XS. So these two is now point loads and this one is uniform distributed load. So now consider AC portion. You want to divide the section XX in between here at a distance of X meter from the free end. So now all the three we want to draw here. So before CD and before BD and now AC. So this is the last one now. For that divided section completion. It is uniform distributed load, that means load is distributing uniformly. At that time the load is acting at centroidal axis, that means at the load is acting at center. So all the load acts at the center, that means 2 means at the distance 1 meter it will acting at center. So that is the uniform distributing load. So for that now divide section XX. In right hand side what are the loads? So plus 10, plus 20, plus this load also we are acting. So plus 4 into x minus 3, because this is a load acting on this load. No, so this we want to consider this is also a load. So because uniform distributed, no, so wherever the load is acting, so right hand side also we are getting some load. For that purpose this is also we will consider 4 into x minus 3 we will consider. Next, likewise bending moment. So bending moment is what? Minus 10 into x minus 20 into x minus 2 minus 4 into x minus 3 into x minus 3 by 2, because load is acting at center. This load is what we think 4 into x minus 3 is, we think this is a load. So now this load is acting at central, that means now we consider this one only. So this one again acting at the central axis. So now first before this is center. So right hand side what? So this one. In this one again there is a center, that means in bending moment diagram we will write x minus 3 into x minus 3 by 2, because x minus 3 is acting at center. So this is the calculation of bending moment. So see the calculation. So shear force is plus 10 plus 20 plus 4 into x minus 3. So in the place of x we are saying xx, no. Why? Because in the place of x we want to substitute the value of 5. Why? Because why we want to substitute 5 here? Why? Because means the total load is acting at 2 meters, this one, plus the total we want to consider 2 meters plus 1 meter plus 2 meter. So that is equal to 5. So for that before in BD portion we want to in the place of x we want to place it 2. In CD portion in the place of x we want to consider 3. So this total value we will consider. At the portion of AC in the place of x we want to substitute the 5 here. See here, in the place of x we want to substitute 2 here. And likewise here also in the place of x we want to substitute the 3. After calculation we get some values. According to the values we want to draw the shear force and bending moment like this. See, in shear force for portion this portion CD we have a 10 kilonewtons. For portion BD we have 10 kilonewtons shear force. And next bending moment diagram for this is minus 20 kilonewtons. So shear force always we want to draw like this, and bending moment it will becomes like a slant inclined line. So then after that there is no load acting in between the BD. For that we want to draw the constant line, and again at point D we have 30 kilonewtons. See here we get a 30 kilonewtons here plus 30. So that's plus 30 here, and in between there is no any load. So for that constant value, and again wherever we get a uniform distributed load, at that time we want to draw this some inclined line. So that is a, see here this one. So and likewise for bending moment diagrams, so we get a portion BD minus 20 no. So it is inclined for bending moment. So in shear force it is vertically upwards. So now here we are writing some slantly, and then for portion CD we get a minus 50 kilonewton meter. So that value, that is approximately we want to draw. So there is no accurately for drawing the diagram. Approximately we want to show some variation for minus 20 to minus 50. So some variation. And next at portion AC we get this is portion AC uniform distributed load. For that we want to start the parabolic curve. So in that, so for uniform distributed load, for like the point load, this slantly we want to write. So this is a way of solving the problems in shear force and bending moment diagrams. So thank you for watching this video. Please subscribe my channel. Subscribe the MMK Creations. Thank you for watching this video.